Okay, so last section we're going to take a look at is 2.4, which is on solving linear inequalities. Very similar to solving linear equations like we did yesterday. Almost exactly the same thing. The only difference is if you multiply or divide by a certain number, you have to remember to do something. We'll talk about what that is if you don't remember in this lesson. Okay, so all the problems you see today, not going to have an equal sign. It's going to be replaced by an inequality symbol. Can someone remind me, what's one of the inequality symbols we use? Alex? Greater than? Yep, another one. Scott? Less than? Dominic?
Greater than or equal to.
Greater than or equal to. And I don't think we said less than or equal to. So you're going to see one of those symbols in place of an equal sign in every problem. There's a couple examples of inequalities. The one on the right, that's a conditional inequality. If you pick a number bigger than 4, it will work. If you don't, it won't. The one on the left, well, there's no algebra in that at all. It's just a true statement. 3 is less than 8. So the way that you can tell if a number is a solution to an inequality is just like you do with an equation. You take the number, you fill it in, and you see if you get a true statement. So let's look at this one. Let's say I fill in 5. If I want to know if 5 is a solution to that inequality. Replace the x with 5. What's 3 times 5? 15. Is 15 greater than 12? Yes, then 5 is a solution. How about 4? 3 times 4 is 12. Is 12 bigger than 12? No. 12 is equal to 12, but it is not bigger. So that's how you check if something is a solution. Plug in a number and see if it comes out true. Any question on that idea? Okay, so while people are copying that, does anybody remember what the one thing is that's different? If you multiply or divide by a certain number, you have to remember to do something. This didn't happen yesterday. Yep.
If you divide by a negative, the inequality symbol has to flip, doesn't it?
Yep. So if you ever multiply or divide by a negative number, it has to flip. We're going to write that down. I just want to see if people remember. That, yeah, we'll write it down. So one type of inequality that we're going to solve is a conjunction. A conjunction basically means and. It uses the word and. That is an example of a conjunction. X is greater than -1 and less than 3. Basically, a conjunction is like a between two numbers. If you think of this on a number line, so this is -1, 0, 1, 2, 3. If I said to pick a number that's greater than -1, it's like an open circle on -1, and less than 3, it's an open circle on 3. All the numbers that you could pick are right inside there. That's everything between -1 and 3. Now, writing it this way is okay, but a lot of times you're going to see it written in a shorter way. And to take those two and combine them into one inequality, this is how it would look. So the idea is you put the x in the middle, you put the smaller number on the left, you put the bigger number on the right, and both inequalities point to the left. And if you look at it, you can kind of see this piece and this piece in that thing down below. X is less than 3. The part I did in green, that's right there. That's that piece. The other one, x is greater than or equal to -1, is right there. It's just written the other way. X, and then it's pointing at the -1. X pointing at the -1. So there's the two pieces combined into one. Is there any question on that? I know it's Algebra 1, but it might have been a couple years ago. Any questions on the difference between writing it either way? Okay. So as I said, this is a between statement. It means it's every number between -1 and 3. Now, this type of interval, I'm going to explain what this means, but this type of interval is called an open interval. Open means you cannot include the endpoints. So if I said to you, pick a number between 1 and 10 on the open interval from 1 to 10, that means you could pick 2 through 9. If it's an open interval, you're not allowed to pick the endpoint. What do you think the interval is called if you could pick the endpoint? I guess, Dominic? Yeah, it's called a closed interval. So I'm going to talk about a few different terms you can use to describe an interval. One is called open, one is called closed, so we'll go over that. Another one is called bounded, and another one is called unbounded. So let's start with that. Let me start with what's called a bounded interval. And then I'll describe the other three. So the idea of a bounded interval is that the starting point and the stopping point are numbers. And if you think, well, aren't they always numbers? No, there's a symbol we've been using that means the interval goes on forever. That's unbounded. Bounded means it starts at a number, it stops at a number. So the first one, this is what we call a fully closed interval. It starts at A, it stops at B, and it includes A and B. If you wanted to see it as a graph, it would look like this. Here's A, there's B, closed circle on A, closed circle on B, and the answer is everything between them. So if I said to you, pick a number between 1 and 10 on the closed interval from 1 to 10, you could pick 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10. You can include the endpoints. The next one is what we call an open interval. So open interval would look like this. It'd be almost the same thing, except what symbol do you think I would use on the A and the B instead of what I did? Yeah? An open circle. Yep. Open, open, shade between. So an open interval includes all the numbers that are between two values, but it doesn't actually include the endpoints, the A or the B. Now we can also have what's called a half-open interval. Half-open means you can include one, but you can't include the other. So half-open would look like this. And shade between. That's a half open interval on the right. And what do you think the fourth type is? Yeah.
Closed on the left. Closed on the right, open on the left.
Yep, just switching which one is open and which one is closed. So now this is a half open interval on the left. I'll let you figure out what the picture would look like. So this means do not include A, but you can include B. And again, these are all bounded. They start at a number, they stop at a number. Now we're going to talk about unbound. What symbol do you think would have to be in your interval somewhere if it's unbound? So what do you think it means if an interval is unbound? About night?
That it's not like a line, like it's not just going. I don't know.
So we know that if it's bounded, it means it starts at a number and stops at a number.
Yeah. So it goes beyond the number.
Okay. Yeah.
Who's going through?
Yeah. And what symbol do we use to indicate that? Scott?
Would it be like the R thingy and all those numbers?
Yes, it would. So that would mean it would go on forever. So, like, if something had no upper limit, what symbol would you put to represent? Yeah? Infinity. So if you write an interval and it has an infinity in it, then that is unbounded. Unbounded intervals always use either a negative infinity or a positive infinity symbol. Now, can you reach infinity? No. So that means you would always put what kind of symbol on it? Parenthesis or bracket? Parenthesis. You can't reach it. So anything that has an infinity symbol needs to have a parenthesis next to the infinity symbol. If you put a bracket next to infinity, you're saying you can reach it. You can't. You can't reach it. So these are different examples of unbounded intervals. This one, these two are unbounded on the left. These other two are unbounded on the right. And I gave you an example where one was open and one was closed. You can also have it unbounded on each end. Negative infinity to infinity. When we talk about a problem and the domain is all real numbers, that's how we usually write it. That's unbounded on the left and the right. And I won't draw a picture for all of them, but if you want to see like this one, the interval from 5 to infinity, that would look like this. Open circle on 5, and then go as high as you want. That's what that one would look like. The one above it would be almost the same thing, except you would fill the circle in instead of leaving it open. 5 to infinity. So any question on that idea? So there's really 3 different ways we can describe numbers. We can describe it as an interval. We can describe it as a picture, Or we can describe it as an inequality. Like this bottom one really means x is greater than 5. That's what that means. Everything higher than 5. So we need to be comfortable with doing it all 3 ways. All right. What kind of interval is that? Is it bounded or unbounded, Cameron? Yep, it is bounded. Is it open, closed, or half open? It's half open. It's a half open bounded interval. Can somebody tell me how I would write this as an inequality? Yep.
Close circle on 5, open circle on -3.
So if we wanted a graph, yes. But this time they want an inequality, so with the less thans and greater thans. Doesn't.
Would it be like x is greater than -3 but less than 5?
So x is greater than the -3 and less than 5.
Is that it?
Not quite.
That's what I got for it.
Yep,
Would be less than or equal to 5?
or equal. Yep. We need the equal because it's a bracket. But everything else was good. So x is greater than -3 and less than or equal to -5. That's how you pronounce this, and you could write it that way. X is greater than -3, and then put AND. X is less than or equal to 5. Any question on that? Come on, let's try another one. -4 to infinity. How would I write that as an inequality? If you're not sure, think about what does that even mean first. Dominic, just tell me, what does that mean? So like if I said to you, this is the answer to the problem. These are the numbers you can pick. Could you explain what numbers this means you can pick? Any number would be this. That's any number. After or what's the difference between this and what I have up above? And what does closed mean? Right?
It means you can, one you can pick it and the other you can't.
One you can pick it, the other one you cannot pick it. So the one we're doing, you can include -4. So it's not just everything greater than -4, but everything and equal to. Everything greater than or equal to -4. So how would you write that as an inequality? Everything greater than or equal to -4. Yeah.
So it'd be -4. Then you put less than or equal to x. But x has to be less than infinity.
So x is less than infinity. You don't have to write that part because I know x is less than infinity. Everything has to be less than infinity. So this is all you really have to say. And sometimes people say it this way too. That's the same thing. X is greater than or equal to -4. Right, so that's an unbounded interval. It goes on forever. All right, let's try this one. 1, is that a bounded or an unbounded interval?
Bounded?
Yep, that's bounded. It starts at a number, stops at a number. And Lucas, is it open or closed?
Open.
So open would mean it has the parentheses.
Oh, no, close.
That's closed. Closed means you can pick the -8 and you can pick the -3. All right. So anyone think they could give me that as an inequality? Yeah, Cameron?
The -8 is less than equal to 9, less than equal to 3.
Less than or equal to what?
Negative.
Negative. Yep. Exactly. Those mean exactly the same. Okay, any questions on it? So what's this top one called again? What kind of notation is that? That's a...
Close.
Well, it's a closed on the left, closed on the right, but this whole thing is called a what? It is bounded, but it's a bounded. Is it a bounded? No, it's not an inequality.
Interval, right?
That's an interval. Okay? So if they ask you for an interval, they want this. If they ask for an inequality, they want the one below. So that's the difference. Yeah.
So it being bounded or not bounded, does that just mean like the parentheses around they just have like the same thing?
Bounded and unbounded means whether or not you have the infinity symbol.
Oh,
Just think about infinity, it goes on forever. It never stops. There's no limit. So that's unbounded. Parenthesis or bracket has to do with whether it's opened or closed. So two different ideas. Okay, so we did taking an interval and changing it to an inequality. Now let's take an inequality and change it into a graph. Okay, so we'd have to put some numbers on here. And what symbol would we use on the 2? Yeah?
Close.
Closed. And there's actually 2 symbols we can use to represent closed. What's one of them?
For what?
So like, what am I actually going to put right there?
Like a circle.
What kind of circle?
Like a drawn circle.
Yep, so we can do a filled-in circle. Or we could use,
Close bracket.
the bracket. Okay, because that's what you normally use when it's closed. You use the bracket. So you can either put a closed circle and shade to the right, or you could do a bracket and shade to the right. You don't have to do both, you may have to do one. But they're both correct. Any questions on that? All right, let's try this one. X is less than 5. Abigail, what number am I going to put a symbol on here? The 5. And can you tell me what symbol I could put? Yep, we can put an open circle, or I could use a parenthesis. I'm just going to do it one way. Let's do open circle. And this one says everything that's less than 5. So which way would we shade? Yeah, we're going to shade to the left. Everything less than 5 is that way. And one more of that type. The first 2 are unbounded. It's unbounded because there's an arrow on one end and it keeps going. If it keeps going, it's unbounded. There's no limit. This is not unbounded. This last one is bounded. It means it starts somewhere and it stops somewhere. It will not have an arrow. Okay. Kiana, where does this interval start? At -1? And what kind of symbol would you put on the -1? Well, it's including it. So when we're including it, we don't use an open circle. We use a closed circle. The other symbol she could have told me was a bracket. But once you start the problem and you decide you're using circles, you want to use circles for the whole problem. Don't switch to using brackets or parentheses at this point, because we've already decided on circles. Okay. So now, what kind of symbol are we going to put on 3?
An open circle.
Yep, open circle. And Tony, what do I shade?
In between -1 and 3.
Yep, just like that. Any questions on? So that is the practice with the 3 different ways: intervals, inequalities, graphs. Okay. So let's actually look at a problem that we have to solve. Okay, so we haven't really done any solving. We've just done different ways you can write your answer. So I asked you earlier, does anyone remember what you have to do if you multiply or divide by a negative? Someone reminded me, you have to flip the inequalities. So you're going to use pretty much the same steps as yesterday. Okay, but the difference, if you multiply or divide by a negative, flip the sign. You gotta flip it. So we'll try a few problems where we do them algebraically, and then we'll do. I'll show you if we have time at the end on the calculator. Okay, how to do it. Now remember, you only flip it if you multiply or divide by a negative. You never flip it when you add. You never flip it when you subtract. So again, not an equation I would start out with, not an inequality I would start out with in Algebra 1, because it has a lot of steps, not a lot of steps, but it's got distributive property. It's not the simplest inequality, but hopefully we know what to do with that. Austin, could you tell me what side I would start with first to be able to do something to?
The left side.
Yep, we're going to start with the left. And what would you do?
Would you distribute?
Yep, we're going to distribute that 3. If you want to do 2 things at once, you can. It's up to you. 3 times x is 3x. And how about, Fiorella, what's 3 times -1? And then add 2 to that. -1. So I distributed and I combined like terms at the same time. You don't have to do that if you don't want. Okay, then you'll have to do 2 separate steps. Okay, now depending on how we solve this is going to control whether or not we end up dividing by a negative number. We can choose if we want to do that right now. So what would be my next step? Yep.
Add the 1 to the 6.
Okay, so we're going to add the 1 to the 6. I will tell you that now means we are dividing by a negative. We just caused that to happen, which is fine. We can do it that way. But we just have to remember. So add 1 to both sides. That's gone. 3x is less than or equal to 5x plus 7. Okay. Jackson, what would I do now?
You subtract 5x.
Yep. And this is where we're going to end up in the next step, creating a negative. So the 5x is gone. The only thing on the right is 7. But Dominic, what's on the left now?
Negative 2x.
Yep, and that's fine. We just have to remember when we divide each side by -2 to do what? Flip it. So divide by -2, divide by -2. That's the first thing I'm going to do before I even do the math, so I don't forget. Flip it. So now I have x is greater than or equal to. Alex, what would I have on the right? Yeah, you could just write it as -7/2. You could also do -3.5. That would be fine. Any question on solving that? So that's a linear inequality we just solved. Okay. So let's look at, maybe we'll do one very similar to that, except I'm going to show you how to do it on the calculator. Now, a linear inequality that's the same difficulty as the last problem we just did, I would never do that on the calculator. It's simple enough, I can just do it. But we might get some that are not as simple as that. So, one method to solve these on the calculator is to get 0 on one side. Kind of like you're doing it if it was a quadratic problem. Get everything on one side, get 0 on the other. And then calculate a root. Okay, so we'll try that method first. So get everything on one side and then calculate the root. Alright, so let's solve this. Using the method I just showed you, you got to get everything on one side. So how about, Sam, can you tell me the easiest way to get everything on one side?
You subtract 2 from each side.
Yep. So subtract 2 from both sides, and you get 4x minus 3 is less than 0. Let's type that in. Now, you can't type an inequality symbol in the y equals screen to change that. So you have to leave it as an equals. So just type it in. 4x minus 3. And what we're going to do is hit zoom 6. Now, when I draw that, this is going to show up as a line. I want to know where that line is less than 0. If you're looking at an axis, less than means under. So if my line looks like this, I want to know that section. Where is it under the 0? Above, well, that would be the other section. So let's look at our picture. It's pretty much exactly what it looks like. When it says less than 0, I want the section that is below the x-axis. That's all this. Up to where it crosses. Can I include where it crosses or not include it in this one? Don't include it. It doesn't say it can equal 0. It says it has to be under. So there's a hole there. It's everything from this value down. So let's see what that value is. Now we have to calculate that root. This is what we did yesterday. Second, calc 0. Pick a point to the left, right, and guess. Okay, so I get 0.75. If I pick numbers below 0.75, that's going to be heading to the left, and in that part, my graph keeps going down. If I pick numbers to the right of 0.75, my graph is going up. That's not the part I want. I want the part that is below 0.75. And that's the answer. Any question on how we got there? So once you get this number, it's either everything below 0.75 or everything above. It depends which way they want. Is it less than 0? Which means they want the part that's under? Or is it more than 0? They want the part that's above. Questions on that? So that's the first method. And you can use that method all the time. That method works fine. The second method is, instead of getting 0 on one side, you just leave it the way it is. Leave the 4x minus 1 on the left. Leave the 2 on the right. And what we're going to do this time is put the left side in y1, put the right side in y2. And we're not going to calculate a 0. This time we're going to calculate an intersect. We're going to get the same answer. It's just a different way to do it. So let's put 4x minus 1 into y1. Put 2, which is the other side, in y2. So 4x minus 1, that's the blue. So that one is, that's the blue. And in mine, the 2 is red. So what I'm looking for is where the blue is under the red. Where is the blue less than the red? If you want to think of it as a color. Right, let's graph it and see. There's the blue. There's the red. And I'm looking for where the blue is under. So let's calculate the intersect. Second, calc. Intersect. I think we've done intersect before. You just hit enter on the blue, hit enter on the red, and put your guess kind of close, but the guess doesn't really matter. And I get 0.75. Now I just have to decide, is it everything above 0.75 or everything below? I want the section where the blue is under. That's the ones that head left. If you start heading to the right on the blue line, all of a sudden you're going to get above the red. That's not what they want. We want to be below. So, whether you do it with an intersect or whether you do it with a root, you will get the same answer. It's just two different ways to do the same thing. You pick whichever way you want to do it. And we already did it, so I'm not going to do it again. Any question on that? Okay. So we had inequalities before that have an x in the middle, a number on the left, and a number on the right. That's like a double inequality. To solve a double inequality, it's almost like solving a single inequality, except whatever you do to the middle, you have to do to the left and you have to do to the right. So if I wanted to solve this one, I would want to get rid of that 2. The goal is to get the x by itself in the middle. this is how you would do it. You would divide everything by 2. So remember, whatever you do to the middle, you have to do to the left and the right. Same rule applies. If you had divided by a negative, you would have been flipping all of these inequality signs right now. And then there's one thing after this, and that's it. So let's see if we can get x by itself in now. So don't worry too much about the left and the right. Focus on what's in the middle. That's what's going to tell you your first step. Anyone think they know what we would do first to start to get the x by itself? Tony?
Times the whole thing by 3.
Yep. And remember, if you do it in the middle, do it to the left, do it to the right. That's your first step. When you times by 3 in the middle, that's gone. How about, Alex, what do I get when I do negative 3 times 3?
Negative 9.
Negative 9. And in the middle, the 3 is gone. And on the right, Kiana, 5 times 3, 15. Okay, good. So that's your first step. What would be your second step? Yep, 90.
Subtract 5 from all of the apples.
From all of them. Minus 5, 5, and 5. That's gone. Negative 9 minus 5 is negative 14.
I have a clarification question.
Yes.
Because it was just subtraction, it doesn't change the signs, right?
No, does not change it. Adding and subtracting never change them. Only if you multiply or divide by a negative, which actually won't happen in this problem. And what would be my last step? Divide everything by 2. And because that 2 is a positive 2, don't flip anything. So negative 7 is less than x, which is less than or equal to 5. Okay, we got multiple ways we could write that if we had to. Question done. All right, so last thing. Yesterday we finished up with solving equations that had absolute value. Today we're going to finish up with solving inequalities that have absolute value. And it's almost identical. Almost the same thing. So yesterday you might have had a problem that looked like this. Absolute value of x plus 3 equals 6. Today, it might look like that. So the first thing we have to do is make sure the absolute value is by itself. It's the same first step as yesterday. You don't want to have something like this. You don't want extra numbers outside the absolute value numbers. But I think in most of the ones I give you, there won't be. So we make sure the absolute value is by itself, and then we split it into 2 problems. Based on what we did yesterday, anybody think they know what the first one would be? You split that into? Yep.
X plus 3 is less than or equal to 6.
Exactly. That's the first one. X plus 3 is less than or equal to 6. It's the same inequality. You just take away the bars. Same first step as yesterday. So you'd have x plus 3 is less than or equal to 6. And anybody think they know the second one? You have to be a little careful here because there's an inequality sign. So it's what you did yesterday, but there's one more thing involved. Yep?
X plus 3 is greater than 6? Or equal to?
Greater than or equal to. And what did we do with the number on the other side yesterday? Made it a negative. That's the second one. And that's how you'd solve this problem. I'm not going to do it, but that's how you would do it. So the second inequality is the same as the first one, except you take out the bars, and you make the number negative and flip the sign. So the only thing that's extra from yesterday is that when you do the second one, you have to remember to flip the sign. Now, when you do the problem, when you write your answer, there's 2 words you can pick from. Your answer is either something and something, something or something. And it makes a big difference if you use the word and or you use the word or. The way you can remember what word you're supposed to use when you write your answer is if the original problem has a less than symbol. A less than symbol always means you use an and. Doesn't matter if it's less than or equal to. Any type of less than symbol uses and, so I remember land. Less than and land. Okay, that's one way you can remember it. Less thans use ands. Greater than uses or. You can even pronounce it so you can kind of remember it. Instead of saying like greater, say it like greater. Say it that way. Greater is an or. Greater. Or. However you can remember. Yes? Yep. All right, so we'll try one of those, and that'll be it. Yeah, let's just do this one, I guess. Let me make this number different. Let's make it a 4. So step 2 is actually the easiest thing you can tell before you even start doing any work. When we write our final answers, is this one going to be an and something, or is it something or something? Which one is this? Yep. This is an and, because the original problem has a less than and. So I might as well write that word down right now. Something and something. Now, split it apart. What's my first inequality that this would split into? This is the easier one. We don't have to do much to it. Yep.
X minus 3 is less than 4.
Yep, just take the bars away. And you could solve that, but I like to get the other one first. So x minus 3 is less than 4. And what's my second one? Yep.
X minus 3 is greater than negative.
Flip, make negative. And once you do this, there's 2 of them, but they're usually relatively quick and simple to solve. So just add 3 on both sides. X is less than 7. And x is greater than how much? Negative 1. So x is smaller than 7, but bigger than negative 1. Yeah, that makes sense. You could do that. And that's it. So that's an absolute value inequality. Any question on that? Okay, so let me put up a couple reminders. So for tonight, you'll have the take home, which will open at 2:40. And it'll be due, we don't have class tomorrow, so it'll be due 8 a.m. on 9/23. That's 8 a.m. Eastern time. And that's 9/23 of this year. What else? So you'll have 100 minutes.
Could I have your attention, please, for several important?
Okay, so you have 100 minutes. If it's late, once 8 o'clock hits, it's just going to shut it off. You won't be able to do anything. Does anybody have any questions or concerns about the take-home? The test is going to cover sections Monday to Thursday, which was 1.5, 2.1, 2.3, and 2.4.
It's your fault.
Any other questions or concerns about the take-home?
One more announcement.